Hello everybody! Welcome to Creating the Basic Adaptable Game Engine Library, Part 7, Rectangle Theory. In any video game, the objects in your game world need to interact with each other. And the easiest way to handle interaction is to say the two objects have interacted when they overlap. Well, how do you determine when two objects overlap? We'll assume that every object in our game is rectangular shaped. We're going to create a rectangle class, and then we'll use that to determine when two objects overlap. So we're using rectangular boundaries for all our sprite objects. So we need to talk a little bit about rectangles, the properties that define a rectangle, and more importantly, how to determine when two rectangles overlap. So rectangles are pretty straightforward. We'll specify a rectangle with four pieces of information. First, the coordinates of its top left corner. The left is the x coordinate of this edge, and the top is the y coordinate of this top edge. The other two pieces of information we need to specify the shape of a rectangle, its position and size, we need the width of the rectangle and the height of the rectangle. Now, to make our code easier, when we eventually write a rectangle class, we'll also define two more values to make our code more readable. The right edge of the rectangle can be calculated from the coordinate of its left edge plus its width. The bottom edge of a rectangle can be calculated from its top coordinate plus its height. And those values completely specify a rectangle. There's also a subtle assumption that we should be very clear and point out. This class is assuming that the coordinate axis of our world is oriented in this direction. The positive x-axis extends to the right, while the positive y-axis extends down. This might be a little bit different than what you've grown accustomed to from perhaps an algebra course. In algebra, you often see the positive y-axis pointing upwards. But it's standard practice in computer graphics to specify the origin to be the very top left corner of your drawing area. Then the x-axis extends to the right, and the positive y-axis extends downwards. Now that we know what values we can refer to when we're talking about a rectangle, we can talk about how to test when two rectangles overlap. As it turns out, it's actually easier to talk about the opposite condition. When do two rectangles not overlap? There's a result called the separating axis theorem that says the following. If two rectangles do not overlap, then it is possible to draw a separating axis between them. And if they don't overlap, we can draw a line like so. And there's actually four cases that we need to consider to verify that rectangles do not overlap. So in each case, we have a blue rectangle, which I've called this, and a non-overlapping rectangle, which I've called other, could be in one of four positions. For example, the other rectangle might be to the right of this rectangle, in which case we can draw a separating axis in this location, and we can check for this condition by saying the other rectangle left side is greater than this rectangle's right side. The second case would be when the other rectangle is below this rectangle, in which case we would say the other rectangle's top side is greater than this rectangle's bottom side. Now remember, this is greater than because y values increase as we move down. The third case says that the other rectangle is above this rectangle, if the other rectangle's bottom side is less than this rectangle's top side. The fourth case says that the other rectangle is to the left of this rectangle when the other rectangle's right side is less than this rectangle's left side. If any one of these four cases is true, that means that the rectangles do not overlap. So, when we get down to writing some code, we'll check to see if rectangles do not overlap, and then we can negate that condition to determine if they do overlap. So that's the little bit of theory we need. In the next video, we'll talk about how we're going to set up the rectangle class.